here we go. Sampling design. Think about sampling something you're cooking. I love to cook. My son loves to cook with me, so we do a lot of the cooking in our house. So think about sampling something you're cooking. You taste or you examine a small part of what you're cooking to get an idea about the dish as a whole. That's pretty much an example of sampling. Opinion polls. These are also examples of sample surveys. They're designed to ask questions of a small group of people in the hope of learning something about the entire population. It is simply too difficult to ask the entire population the question, so we do an opinion poll, and we ask a small group of people, and we try to make some sort of inference based on what they're saying. That's an example of sampling. How do we go about gathering the data? That's the most important piece of information. If we're going to do a sample of any kind, the manner that we gather the data is the most important thing. So one of the ways we do this is through surveys. A well-designed survey, you put it out there, you have people answer the questions, you can gather a lot of information that way and make some pretty good judgments and conclusions based upon that. Another example, opinion polls. Presidential opinion polls, Congress satisfaction opinion polls. There's lots of different opinion polls out there. Interviews. One of the good ways people is actually call. You get those phone interviews you get the interviews of phone sometimes, where people call and they ask you questions. They interview you based on your opinions, based on what you're feeling. Those are examples of interviews. Studies, which are a little bit more. There's different types of studies. There's an observational study where they would just observe people doing whatever it is they're doing and write down notes about that. Retrospective studies, where they study the past. Prospective studies, where they study the future, what might happen, what do you think is going to happen, those kind of things. And then experiments. And experiments we'll talk more about in our next video, but these are all different methods of gathering data. So let's get into some definitions. So first, a population. What do I mean when I say the population? It is the entire group of individuals that we want information about. Now, it might not be everyone in the entire country, because we might not be interested in everyone in the country. We may be interested in simply teenagers. We want to know what's the favorite pizza that teenagers like, in which case the population would be teenagers. A census. A census is a complete count of the population. Some of you should realize, hopefully all of you should realize in your American history studies, that we do a census in our country every 10 years, and that's mandated by the Constitution. And this is basically so that we know what our population is. Alright, so that's what a census is, a complete count. Now, a census is a great tool, and some people may be asking, well, if a census is so great and we get a sample of the entire population, why not just do that all the time? Why do we need to even bother with sampling when we can simply do a census? Well, first of all, they're not terribly accurate. Look at the U.S. Census. It has a huge amount of error in it. Plus, it takes a long time to compile the data, and that sometimes makes the data obsolete by the time we get it. It's very expensive. That's why they only do it 10 years. It is perhaps impossible. Think about this example. Suppose you wanted to know the average weight of the white-tailed deer population in Texas. Would it be feasible to do a census? I can tell you I spent a lot of time in Texas, and when I was in high school I spent a lot of time hunting white-tailed deer in Texas, and you simply can't do a census. There's no way to count them all. If you were using destructive sampling, you would destroy the population. So, for example, if we wanted to measure the breaking strength of soda bottles, we couldn't do a census, because that would mean we would break every single soda bottle in existence, and we can't do that. Lifetime of flashlight batteries. If we want to know what's the average lifetime of a flashlight battery, what are we going to do? Drain every single flashlight battery made? We can't do that, so a census in that case is not going to work. Safety ratings for cars. In order to determine that, if you were using a census, we would have to destroy every single car. Alright, so that's not going to happen. It doesn't make sense. Okay, a couple of other definitions. First, a sample. A sample is a part of the population that we actually examine in order to gather information. So remember, the population is the entire thing we're interested in. A sample is simply a small part that we actually examine. The sampling design refers to the method that we use to choose the sample from the population. Alright, so the sample is actually the part of the population. The design is the method that we used to choose that sample. And then the sampling frame is a list of every individual in the population. Alright, so that's a list. That's the sampling frame. Those are 3 big definitions that you should write down. Okay, so now we get into some different types of sampling designs. A simple random sample, this is the gold standard, consists of n individuals, some number of individuals from the population, chosen in such a way that every individual has an equal chance of being selected. So suppose we were to take a simple random sample of 100 HH students. We put each student's name in a hat, and then we randomly select 100 names from the hat. Every student has the same chance of being selected using this method. This is a simple random sample. The second part is every set of n individuals has an equal chance of being selected. This is the part that can get a little tricky. So a simple random sample has to have 2 parts. This is a great multiple choice question on an upcoming test, is what is a simple random sample? Give you an example, give you a scenario, and you have to figure out, is this or is this not a simple random sample? And it's usually the second part of the definition that causes people trouble. So for example, not only does each student have the same chance to be selected, but every possible group of 100 students has the same chance to be selected. In order for it to be a simple random sample, it has to be possible for all 100 students to be seniors. Now that might not seem fair, but that's what makes it a simple random sample. If I'm picking 100 students at random from the school, it has to be possible that all 100 of them would be seniors. Not likely, but possible. Now, that leads us in, how do we guarantee randomness? Well, one of the ways on the AP exam that we guarantee randomness is using something called a random digit table. Every entry in the random digit table is equally likely to be any of the 100 of the 10 digits. And the digits are independent of each other. Right? There's no dependence whatsoever. There's a random digit table in the back of your statistics textbook, and we're going to be using that a lot. So here's a part of it. The following is part of the random digit table that's on the last page of your textbook, and you can see that they have the random digits lined up across. So first, the numbers you can read across. You can read the numbers vertically. You can read the numbers diagonally. Right? You can choose how you want to go about reading them. So here's an example problem. Suppose your population consisted of these 20 people. You can see a list of names there. Use the following random digits to select a sample of 5 from these people. So what you would do is we're going to use double-digit random numbers because we have numbers going up to 20. We're going to ignore any number greater than 20. We're going to start with row 1 and read across. So the first number we would sample 45. We would ignore that. There's no 45 on our list. The next one is 18. Okay, 18 is Tracy, so Tracy's been selected. The next one is 5. That's Edward. Then 13. That's Matthew. Then 71. It's too big. We ignore it. Then 1. That's Aiden. 55. Ignore. 80. Ignore. 15. And we get Opus. And now we have our 5 people. That's the way you would use a random digit table in the back of your textbook. Okay, back to our sampling methods. Another sampling method, convenience sample. We just ask whoever's around. So for example, man on the street. Right, the man on the street survey. It's cheap, it's convenient, however, it's often quite opinionated or emotional. It's because you'd ask yourself, which men on which street? If we were to ask about gun control or legalizing marijuana on the street in Berkeley, California, or in some small town in Idaho, we'd probably get totally different answers. And even within an area, answers would probably differ. If you did the survey outside of a high school versus outside of a country western bar, you would get different opinions, different places. So convenience sampling, it's easy, it's cheap, it's not great. It's not a great way to do things. Voluntary response sampling. Individuals will choose to be involved. They make the decision whether they want to do this or not. These samples are very susceptible to being biased. Different people are going to be motivated to respond or not. We sometimes call these, or you see these referred to as public opinion polls. They are not valid, they are not scientific, and you have to treat them with a large, basically you can't take what they say for granted. It's not going to be true most of the time. The sample design systematically favors a particular outcome because it's people who are choosing to be involved. So here's an example, a famous example of this. Ann Landers, she's a columnist, she summarized the responses of readers. 70%, she had 10,000 people write into her. 70% of the parents wrote in to say that having kids was not worth it. If they had to do it over again, they wouldn't. So she asked her readers to send her letters basically saying do they regret having kids. 70% of the people wrote back saying, not worth it, shouldn't do it, wouldn't do it again. That's a biased poll, because most of the letters to newspapers are written by disgruntled people. They're people who are pissed off. Maybe they just had a fight with their kids and they saw this and they said, I'm going to write her in. So they wrote a letter. And of course they got this overwhelming response. A random sample showed that 91% of parents would have kids again. So you can see the difference between what a random sample shows versus what a voluntary response sample shows. So be very careful with voluntary response samples. Okay, so we spent some time talking about two types of sampling methods that are not good. Well, here's one that's very good, a stratified random sample. The population is divided into homogeneous groups. We call those groups strata. So homogeneous groups are groups that are alike based upon some characteristic of the group members. It could be hair color, it could be gender, it could be homerooms, it could be grade level. Any way we want to divide them up. We then pull a simple random sample from each strata. Right, that's an example of a stratified random sample. First you divide it into homogeneous groups, then we pull a simple random sample from each one. So suppose we were to take a stratified random sample of 100 HH students. The students are already divided by grade level, so therefore grade level can be our strata. Then we're going to randomly select 50 seniors and 50 juniors. Right. That would be an example of a stratified random sample, as long as our population was only seniors and juniors. A systematic random sample. You select a sample by following a system. You have some sort of system involved, every 10th person, every 30th person, or whatever. And then the randomness occurs, where do you start? So here's an example of that. Suppose we want to do a systematic random sample of HH students. First, we get a list of all the students. There's approximately 2,000 students. If we wanted a sample of 100, that'd be 2,000 divided by 100, so that's 20. Select a number between 1 and 20 at random. That student will be the first student chosen. Then we would simply go down the list and we would select every 20th student. So the system is, we're selecting every 20th student. The randomness is, where do you start? We're going to randomly pick a number between 1 and 20. That's where we're going to start, and then we're going to start picking every 20th student from there. So that's an example of a systematic survey, or a systematic sample. Next up we have a cluster sample. It's based on location. Location, location, location is all about clusters. You randomly pick a location, and then you sample everything there. That's the difference between a stratified. A stratified, we take little pieces from each strata. In a cluster, we base it upon location, we randomly pick a location, but we sample everything in that location. So suppose we wanted to do a cluster sample of HH students. One way to do this would be to randomly select 10 classrooms during a second period. Then we're going to sample all the students in those rooms. For a stratified sample, we would randomly pick 1 or 2 students from every single second period. For a cluster sample, instead of going to every single second period, we're just going to pick 10 second periods and we're going to sample everybody in those rooms. That's an example of a cluster sample. Cluster sampling is very useful when it is difficult and costly to develop a complete list of population members. So for example, in a grocery store, if we wanted to catalog the items in a grocery store, it would be very difficult to do that because there are so many thousands of different ones on there. Instead, we could divide it into a cluster and then sample everything in that cluster. That would be an example of a good way to use it. If the population members are widely dispersed geographically, so for example, Toyota dealerships in North Carolina. North Carolina is a pretty big state. It would be time consuming and difficult to sample every single Toyota dealership in North Carolina. So instead, we may separate the state into 6 or 7 or 10 different regions, and then we would sample every single Toyota dealership in that region. That way we're not driving all over the state of North Carolina. Instead, we're only looking in that region.
That's all, folks.